right, so today we'll do a really cool application of second-order ODEs. In particular, we will see what happens when you attach a mass to a spring. And before I state and derive the equations, I do want to show you this really cool demo that I found where you can literally attach any mass to any spring. Now, let's see, for instance, what happens when you attach this 250-gram mass to this spring. And whee! It goes up and down like a bunny. And in particular, we will show later that the motion here is indeed sinusoidal. And the cool thing is you can change a couple of parameters. One is called the spring constant, because a feather spring is not the same thing as a rusty spring. That's what the spring constant signifies. In particular, if you increase the spring constant, it seems to go a bit faster, which we'll see as well. And not only that, we can incorporate the effects due to gravity. So this is what the motion looks like on Earth, but on the moon, where there's less gravity, it seems to be going a little bit slower. And if there's lots of gravity, it seems to bounce around. Another thing that we can change is what's called the damping constant, because in real life, due to friction, you actually expect the motion to sort of stop at some point. And we can see that with this demo. So this is again on Earth with no damping. But if you add lots of damping, then you see that the motion sort of, at least your eye, stops at some point. And we will also see this when we will study the equations. And last but not least, not this in demo, but we can also incorporate an external force, which we'll see very soon.